Good morning, students. Today we are going to see about VLSI design introduction classes. VLSI, very large scale of integration. It consists of 10 to the power of 6 transistors will be implemented in a single chip. So meaning it will be implemented 1 million transistor. Before that we have SSI, LSI, MSI, and now it will be VLSI. After this you have ULSI, and finally we have GSI. So expansion of these are small scale integration, large scale integration, medium scale, very large scale, ultra large scale, and giant scale integration. So giant scale means it will be implemented more than 10 million transistors implemented in a chip. Example for GSI is our embedded system. So today we are going to see about the symbols of transistor. So the top one is showing about your NMOS transistor and bottom will be the PMOS transistor. So we know that only three symbols or three terminals will be visible on the naked eye. One is gate, drain and source. Actually transistor is having one more terminal called substrate. The source and the substrate will be tied always together. And we have two concepts called depletion and enhancement mode. In mode means it is not having the channel, and depletion mode it is having the channel, so that can be represented by using the thickness. Okay, it's showing the thickness, meaning the channel is to be present. In enhancement mode, channel is not there, but the channel is creating by applying the electrical voltages VGS. By applying your VGS voltage, your channel is going to be created electrically. But in depletion, channel is created from the manufacturer itself. So these are the various symbols, and this transistor will be operating in the three region. One will be called it as accumulation region, where your opposite poles and charges will be attract each other and accumulated on one places, and the condition will be VGS is less than 0. And second one is your depletion mode. This depletion mode is nothing but between 0 to VGS less than VT. And third case is your inversion mode. So these are the three modes of the transistor it will be getting working. VGS is less than VT. So why it is called inversion in the sense, if we are taking the P substrate means definitely the holes will be full of in that substrate. But after the conduction, this substrate is full of like electrons. So it will be going to invert. That's why it is called as a inversion layer. And next, we are going to see about the simple CMOS inverter. Top always will be the PMOS and bottom will be the NMOS. The PMOS is to be connected with VDD, bottom has to be connected with the ground. And both we are giving connector tie together and giving us a V input, and this side we are taking as a V output. The other name for PMOS is pull up because it is going to pulling up the voltage to VDD, and here the pulling down to the VDD to be this ground or zero. That's why it is called pull down transistor. So it is like as a it is act as now CMOS inverter. So CMOS expansion is complementary metal oxide semiconductor. If I'm giving the one input for the inverter, it is going to be produce output as zero, because of when one input is applied to both gate of the PMOS and NMOS, this gate will be going to be off. The device will be off for the one input and the device will be on for the P input. So your input will be travel from like this, and it is going to be travel towards your NMOS. So NMOS means definitely it is pulling down to the output zero. If your output will be travel in the upward, that output was going to be the VDD, meaning it is going to be produced the one. When it will be on means that when the input will be zero, then it will produce the output as one. So therefore it act as a inverter. Your input is one, your output will be zero. This zero is happened due to pull down network. And the second input is, if I giving the input as zero, it is going to be produce the output as one because of the pull up transistor, because in that PMOS is going to be on. Okay, thank you, students.